Wouldn't it be great if an industry like pulp and paper could become not just essential to everyday life, but also a major contributor to durable carbon removal, all while securing the future of the mills themselves? That's exactly what we're here to talk about today. We're looking at a major step forward for carbon capture in the pulp and paper industry following the Mobile Test Unit MTU field pilot conducted by CO280 and SLB Capturi at a mill on the US Gulf Coast. With more than 4,000 operating hours and a stable 95% capture rate on recovery boiler flue gas, this pilot validated all key process parameters and demonstrated there are no technical barriers to deploying commercial scale carbon capture plants in the pulp and paper industry. My name is Julie Brinkstad, Strategic Communication Manager at SLB Capturi, and I'm joined today by two people at the center of this milestone. Jonathan Rohn, co-founder and CEO of CO280, and Jon Christopher Knudsen, Chief Commercial and Services Officer at SLB Capturi. Welcome to both of you. We might have listeners right now that are less familiar with CO280 and SLB Capturi. So could I please ask you to give your best elevator pitch of your organizations? And John, I'll hand it to you to get us started.
Yeah, Julie, thanks very much for having me. And JC, great to see you, my friend. CO280 is a developer of large-scale carbon removal projects, and we're really focused on retrofitting pulp and paper mills, beginning in North America. And we're putting large-scale carbon capture plants right at the mill site to capture biogenic CO2 from pulp and paper mills. And that CO2 is processed, it's concentrated, it's compressed, and then we put it in a pipeline, and it's permanently sequestered in geologic storage. And the reason this is important is because capturing, sequestering biogenic CO2 creates high quality, permanent carbon dioxide removal credits that we then can monetize and sell into the voluntary carbon market to customers like Microsoft and JP Morgan and Google and so on, to help them meet their net zero goals. So these are production plants. They're fully profitable. They're project financed, and they're really transforming the pulp and paper industry.
Oh, very good. Jon Christopher, would you like to give a short introduction of SLB Capturi?
Absolutely. So SLB Capturi is a joint venture between Aker and SLB, and we're a supplier of carbon capture technologies for the industrial sector. So we have more than 2 decades now of development and expertise, and we've done a lot of testing along the way and have several full-scale plants either being delivered or just delivered. So we provide carbon capture technology to companies across these industries. It includes cement, waste to energy, bioenergy, and now the pulp and paper mill. So it's a very exciting topic, and it's a very up and coming industry. And we are very glad to be here today to talk about how this impacts the pulp and paper mills.
Very good. It's great to have you both here. And for those of you listening in, please feel free to ask questions in the chat as we go. We'll get around to some of them towards the end. I want to personally learn more about this field pilot and what you guys have done together. So I'm going to start off with you, Jonathan. If you could sum it up for me and a mill operator in 2 to 3 sentences, what is a field pilot, and why did this one actually prove, or what did this one actually prove about pulp and paper CDR?
Well, Julie, I might do 4 or 5 sentences, but I'm going to talk as though I'm explaining this to a mill operator. Okay, so what we're really embedded in the pulp and paper industry, and we talk to mill operators and pulp and paper companies all the time. What we say is this: the context is important. So SLB Capturi has some of the most extensive expertise and experience in developing and scaling up commercial carbon capture machines and plants that capture industrial CO2 from industrial flue gas. They're one of the best in the world. They know what they're doing. The technology works, and it's commercially proven. But the flue gas from industry to industry is a little bit different in chemical composition, and it has not. The technology has not been adapted into the pulp and paper industry yet. So this field pilot that we partnered with SLB and our pulp and paper partner, basically we brought a scaled down version of the technology. We shipped it from Norway to the Gulf Coast. We installed it at a pulp and paper mill, one of the best mills, one of the top quartile mills in North America. And it's called a mobile test unit, but it's a lot bigger than that. It's not a lab unit. It's 10 40-foot containers. JC likes to use the word mobile. It's a big facility, and it actually has all of the process steps that you'd have in a large scale plant. And so we took a slipstream of flue gas from the stack emissions, and we ran it through the pilot unit, and with the goal to verify the performance of the technology and really validate all the KPIs, all the key performance parameters, and we demonstrated that there's no technical barriers. And then finally, we'd say to a mill operator that this pilot was an unqualified success. I mean, we've run a lot of different industrial pilots in all of our backgrounds. We ran this unit for thousands of hours. It operated at an over a 94% uptime, and it validated and met, and in some cases exceeded every single KPI. So unqualified success.
Great. And that kind of leads me to you, Jon Christopher, because as far as I'm aware, this was a new flue gas for SLB Capturi when it came to the pulp and paper sector. So how did you approach applying the carbon capture technology that SLB Capturi has to this pilot?
Well, back in the days, Julie, we in Aker at that time, we decided that in order to develop this type of new technology, we understood the importance of taking industry along the way. And very early, actually back in 2008, we built the first mobile test unit, which is still in operation here in Europe, and saw the importance of being able to show real data on what actually things look when you put it to the right and the individual flue gases on the individual industries. And the way we approached it is that we built a large scale plant at Technology Center Mongstad in 2012. And then we ran this pilot plant, the mobile test unit. And yes, it's still mobile, but it's quite large. And then we saw that we were able to replicate all of the parameters so that we are actually 100% sure that the things that we saw during the tests in the US and in the other tests that we've done around the world are directly linked to the performance of a large-scale plant. So it is really a scaled-down replica of one of our larger plants. And this has been important because there are a lot of test units out there, a lot of lab units out there, which provide some indications that these new technologies will work. But over the years, and what we've seen in history of the carbon capture side, the importance of actually being able to verify individual flue gases for the individual industries and applications is essential for the success of the projects. And this is why we felt it was certainly about time to take this next step and apply it into the pulp and paper mill. Back in the days, of course, it was a lot about coal, right? Coal was really, cleaning coal. That was really the in the early 2000s, that was really what people are talking about. But over the years, we have done a lot of different testing, not just on gas, on gas power, but on all different types of industries. Some of them easy, some of them more difficult. But the nice thing, of course, in this case, is that the pulp and paper test that we've done is really one of the ones that we've seen the best results on. And that gives a reassurance, not only for this individual mill, but also from all the other industry actors that are in the same industry.
Hey, JC, can I just emphasize something you just said? I think it's really important. I think it's really important for our audience to realize that, pilots are done for a variety of different reasons. Sometimes, pilots of new technologies are there to, validate the a scale up, a step in a technology. That's really not what we were doing here. All of the critical components of your technology have already been scaled up and are operating at commercial scale. What we're validating here is really the performance of the amines and the process on this particular chemistry of flue gas. So I think that's really really important for people to understand. So I just want to emphasize.
And sometimes we get the questions, why do you invest so much in these, containers and this mobile test unit? Because it provides not only verification for the industries, it also provides a really important opportunity for us to extend and improve and learn more.
100%.
And if it's something that our company is built upon, and the reason why people come to us is, of course, that they would like to have that learning to reduce the risks in their own project. So when we now have delivered, at Twence, for instance, a waste to energy plant in the Netherlands, the people that are coming after Twence in terms of the next generation with the Just Catch series, the compact carbon capture plants, they want to make sure that the learnings that we have had are actually integrated into the next generation, not only on products, but also how we actually execute these projects. And a lot of that early learning before these first of kind deliveries actually came from the mobile test unit, from hands-on things that we saw in the field that we said, here we need another solution because this is something that we haven't seen before. And this is why, of course, working with companies that have been onto a technology for a long period of time and done extensive testing is a reassurance also for more successful projects going forward.
That's super interesting, because one of the questions that actually came to mind was, why couldn't you just do a simulation of this and look at a model? So thank you for that. Makes a lot of sense. So
and Julie, we do a lot of modeling. That is also important, right? So disbursement models, right? We know for every project we look at disbursement models, and I'm sitting here now in Oslo, where recently earlier this year we took an FID on the Oslo CCS project. This is very residential. We want to make sure, of course, when we install this type of technology, that we meet everybody's attention. So modeling in itself is important. But I mean, more than that, for the individual emitters like the pulp and paper mills, like the BECCS for Heidelberg, and as well as our friends in Oslo CCS and Hafslo and Celsio, all of them want to know that it actually works on their flue gas and their industry. And this is, of course, where the number of hours that we've spent, all the upsets and downsets that we have actually looked upon, all of those type of knowledges, these hands-on knowledges come to bear. And I think that's it. It's really important that it's not just for, and it's as you say, John, it's not about scaling the technology. We did that in 2012. It's about making sure that every industry we apply it to is done successfully.
When you talk about modeling, JC, I can hear our chief engineering officer's voice in my ear. Modeling is great. Model is important. To your point, it gets you to the table. But if we actually want to deploy these projects that are hundreds of millions of dollars up to over $1 billion of capital, we actually need to prove that the technology does what it says it does. So what's the stability of the technology? Validating? It's really about validating the model, validating the energy balance, validating the emissions meet regulatory requirements. So it's validating all those key process parameters in real life, as the mills are operating in real life circumstances. And I think there's another important point that maybe that we don't want to leave out. By actually putting a field pilot in an operating mill or an operating facility, you're also helping to educate the people, the mill operators and the mill team, who are actually going to have to live with the technology, and helping them understand how it's going to work, how it's going to interact and be integrated into their operation, and give them confidence that this technology is going to perform as advertised. So that's another critical aspect.
Great point. It's and I, as an example, I always say that a lot of the clients that are actually in the construction phase, they want to come and visit these pilots. They want to meet the people that
100%.
are actually operating this.
Yeah.
And of course, for me, which is also running our service business, this is really important. Being able to educate, being able to reassure our clients out there that they can run the plant, they understand how it works, and they understand how to deal with the different ways of this, handling upsets and other things. So, and this is also why we need to, we also work a lot with trying to make simulators, which can help also in education, so that they can, really train themselves when they get into the real running of these plants, and optimize how they run the plants so they get successful outcomes.
So what does this mean in terms of the development of, and in specifically this case at the mill? How do you guys go about the development of it? What does it look like on the ground? Like, is there any downtime for the mill? Can you explain a bit about the process of the actual development of a CCS project?
You want to go first, John, or should I?
Yeah, I'm happy to take a stab and jump in, JC. I mean, you're talking about a commercial project, Julie?
Yeah.
Yeah. So I mean, these are, first of all, these are complex projects. They've got lots of different work streams to actually develop the project from, concept right through to FID and then to commercial operations, and it takes years to put these projects together. So we go through a very rigorous FEL stage-gated approach where we with increasing levels of detail of the design and the engineering of the capture plant, and then all of the systems integration, how the capture plant is integrated into the mill. So we do that in steps. We have an engineering team here at CO280. They work with the mills team. They work with the SLB Capturi team. They work with the balance of plant engineering team to go through each one of those stage gates. And we get an increasing level of accuracy on the engineering design and the CapEx and the OpEx. And so that process takes 18 to 24 months to complete right through the process. But in addition to that, there's a whole bunch of other things that have to happen. We have to pre-sell, and we'll talk about the CDR market, but we actually pre-sell all the revenue for the life of the project before we achieve FID. We have to make sure that we've got a transport and storage partner that's going to transport and sequester the CO2. So the technology is important, but it's only one portion of what we have to do. And then we have to pull all the pieces together and all the agreements to finance the project, and so that we can pay JC for his technology. So this is a really multi-staged approach. And then there's the whole construction period on site at the mill, and it's really important that the process of construction and deployment does not interfere with the mill operations. These are production units. They run 350 days of the year, so everything has to be really well organized and really well designed from an execution standpoint, so we don't interrupt the operation of the mill. And then the system will be integrated into the mill operation during one of the planned mill shutdown periods for maintenance. So minimal interruption and maximum impact.
Very good.
And I can see Julie, it's heating up in the comment field, and lovely to see so many of you are joining with questions. Like we did last time, Julie, let's ask the audience if they can also say where they're from, so to get a feel of who's actually listening in today. So if you just want to say hello from various parts of the world, that's also nice to get a feel of what you're listening. But I can see there is a specific question to us, John, on the uniqueness of the pulp and paper mill, because it's fair to say that we started off the coal sector. We saw a lot of cracker gas, more oil and gas related sectors wanting to test our technology and getting through that. And we did a lot of gas power, which is a little bit more difficult because it has this thinner CO2 concentration. We've done various types of hard to abate industries, and now we're at the pulp and paper mills. And of course, we're always really excited to see what are the challenges that are specific, right? Some of these industries are really have particulates, they have dust and those type of things, which we need to look after and we need to model. And then we came to the pulp and paper. And maybe I'll ask you, John, what were you most, I would say, worried about before we started the test? What came to your mind when it came to this type of technology and the pulp and paper mills?
Yeah, I mean, there's a few questions in there, and I'm looking at the chat as well here, JC. But maybe just kind of take them one by one. The pulp and paper industry, first of all, is a very unique industry because 80 to 90% of the emissions that are generated from stack emissions are the CO2. 80 to 90% of it is biogenic. So it's from the way pulp and paper mills work is that the CO2 is captured in the trees, and then the trees are transported to the mills, and the mills produce pulp and paper, and all the byproducts are combusted in these gigantic boilers. And the mills will typically produce anywhere from 500,000 to 2 million tons a year of biogenic CO2. So capturing biogenic CO2, which is carbon neutral, and sequestering it gets us to a carbon negative CDR credit. And that's what we are monetizing. That's quite unique from any other industry. So that's why we're focused on the pulp and paper industry. And the pulp and paper industry worldwide is it's about 600 million tons a year in hundreds of mills across the world. And it's really the largest single point source of biogenic CO2 in the world. So that's why we're focused on the pulp and paper industry. Some of the things we were worried about, and I would say we weren't overtly worried about them, but we wanted to ensure that we really understood how the technology would perform. When you look at these different flue gases, and one of the things we really liked about the SLB Capturi team is that they've got this deep technical experience of running different types of flue gases, everything from FCC crackers at refineries to flue gas from waste to energy plants, cement plants, natural gas fired boilers, and biomass and coal and other flue gas. So they had a deep understanding of the chemistry and the impact of different types of chemical compositions in the flue gas on the performance of their amines, which affects all of the performance of these capture plants. So we wanted to ensure that there's a couple of things we were worried about. Recovery boilers produce in their flue gas, they've got particulate emissions that are kind of an interesting. They're not an inorganic particulate. They're an organic. They're organic salts. And so we wanted to ensure, and SLB did as well, that we were able to pre-treat those particulates to a point where they would not have a negative impact on the performance of the. So we actually tested a pre-treatment system that we're very happy with, JC, I think, and so that was something we wanted to validate. We also wanted to validate the emissions from the absorber stack. These are all regulated facilities. We wanted to understand the energy and mass balance. The largest operating cost of a capture plant is the cost of energy, the steam for the desorber. So we wanted to validate, all of these different performance criteria. And I think, JC, it's safe to say that there were some surprising things that we discovered. One of the things that was just surprising is just the stability of the actual composition of the flue gas through the whole operating. It's incredibly stable. And it makes sense because in a recovery boiler in a pulp and paper mill, the black liquor that's actually is the fuel going in the boiler is quite a processed fuel. So it's quite stable. The fuel's quite stable, and therefore the flue gas is quite stable. So there was a number of really interesting discoveries we made along the way, but those were a few things we were focused on.
It's good to hear from that side, and I can see we have listeners in from Sweden and Vancouver and Calgary and all the way to Singapore. So it's good, a lot of different angles to this. But from our side, of course, having run these mobile test unit campaigns for quite some times, for us this is about how does this type of flue gas compare to other things that we've seen, and usually we actually do a reference campaign as part of the campaign also to look at the traditional amines compared to our amines, because at the end of the day, when we come to the market, it's not just about the process technology, it's about the chemistry that we put into it. And we spent more than 8 years and 96 different cocktails that we mixed with these amines in order to get to some of the amine blends that we're using in our plants today, and that we continue to develop and adjust as we see different things in the flue gases. So stability, of course, is one, as you mentioned. Energy use is, of course, really, really key. This is an area where we constantly need to improve. And, a lot of our newest customers will see improvements like the Energy Saver 2.0, which is, reuses a lot of energy internally in the actual plant itself. And then, as you pointed out, the whole idea of this type of technology is to do good. So it wouldn't make sense if we had emissions that were not good. So our focus all the way from the 2000 all the way up to today, it's been all about the HSE performance. What is it that comes out after we have cleaned the flue gas out of CO2, and how safe can we make these plants in order to make sure that there is no adverse impact to the society around, because these plants, they are usually close to either workers or in the middle of residential areas. Certainly we see a lot of that, for instance, in the waste energy. Then I just wanted to pick up one comment that you said, we saw a very stable flue gas. We see very different stability from flue gas to flue gas. I can tell you we had a lot of interesting discoveries when we're looking at gas power in the UK. We did large scale feeds on gas power in the UK and looked at how are we able to ramp up and down as these gas power plants actually are going off and on, dependent on whether there is green power available, for instance, from wind. And what we saw is actually that we're quite resilient also towards these type of situations. And that gives us a reassurance also that as we enter new industries with less stable operations, we will be able to deliver the same good results. Either it's thin CO2 gases, like down to the 3.5%, which you find in gas power, or all the way up into the 20s that you find typically for cement or coal power.
So JC, then looking at the data from this pilot in terms of stability and energy use and emissions, would you say that pulp and paper carbon capture can scale easily?
Absolutely. In fact, I think John is alluding to it. We were very impressed about the results, and we have had some really difficult campaigns. I can tell you when John and I met for the first time, I told him about some of the cracker gases that we were tackling in the beginning at the Technology Center Mongstad. These were really, really terrible, difficult in all different ways. Yeah. But of course, the upside of actually making it through those type of campaigns is how we learn more about, how much cleaning do we need up front. We learn more about how does some of these situations actually affect, things like, mist generation, which we had to develop specific technology, which is now patented and delivered in all of our plants. And we continue to learn as we see difficult angles towards, what type of emissions that various countries have on their radar. So we need to continue to develop the technology and to make sure that we always stay on top when it comes to the HSE performance. So I'm really, really pleased. Can we say that this has checked out the pulp and paper mills for carbon capture? I think we can actually. And what we've seen for those industries that we've checked earlier using this approach with the mobile test unit with valid results is that once we've actually gone through this process and actually delivered it at scale, it works. And I think that's the most important thing.
I just two additional points to add to pick up on what JC said. All of these stack emissions are regulated, right? So they all they're all permitted. And so they're regularly analyzed there by third-party analytical firms. But the data that's collected for regulations, for stack emissions regulations, is not necessarily the same data that that SLB Capturi needs to see to validate, the chemistry of the flue gas. I think JC, I think we spent something like $500,000 or $600,000 just on analytical analysis of the chemical composition of the flue gas to identify any potential problematic compounds, organic acids, so on, that may have an impact on amine degradation or amine stability, and so it's a very rigorous process. That's number one point. Number two is that when we look at the chemistry of flue gas from one mill to the next mill to the next mill in these recovery boilers, they're very similar. And so we have a high degree of confidence to be able to transfer the learnings and knowledge from this pilot plant. They're not all unique. They're very comparable. We know what to look for, and we know how to mitigate any potential risks going from one project to the next project to the next project. So is it ready for deployment and scale, and give it its confidence? 100%.
Very good. I just want to remind everyone that listens in, we still have time, so send in your questions, keep that chat blowing up with exciting things. I just, based on what I'm hearing from both of you, there's a lot of potential in the pulp and paper industry. So with that in mind, what excites you the most in terms of the potential for carbon removal in this sector in the next years to come? John,
you want me to go first, JC?
Yeah, you shoot first.
Well, this is how I'd answer that. When my co-founder Natalie Katikian and I and our other partners founded CO280 3 years ago, our goal was to lead the world in CDR that meets the highest standards of permanence, quality, affordability, and scale. And that really remains our goal today. The question was really at the time, as the carbon market was shifting away from lower quality avoidance credits to high quality permanent carbon dioxide removal, what's the best way to deliver it? When we looked at all the options out in the market of how we could deliver the best CDR for customers out in the CDR market, we quickly determined that retrofitting pulp and paper mills with commercially proven capture technology and sequestering the biogenic CO2 was the most efficient, cost-effective way to scale up and achieve that. So that's what originally drove our interest into this whole market. Today, we've really pioneered the development of carbon capture and removal projects in the pulp and paper industry. We're really excited about what we're doing in the market. We needed to find the best technology in order to make that happen. We're technology agnostic as a project developer. But we really originally SLB was not in North America, and I think we came to North America and laid out the case for why this industry, why North America was a good place to start for carbon capture and pulp and paper, to SLB, to Aker at the time, and Aker is has proven to be a fantastic partner. And we're really excited, Julie, because What this pilot has done is it has propelled and accelerated everything we're doing in our project. The first project that we have is fully sold out. We've sold over $1 billion of CDR for the first 12 years. That project is in final feed design with SLB Capturi and our other engineering partners and our pulp and paper partner. We're expecting to get that to FID in 2026. We've got another 4 projects in pre-feed that are moving towards feed in 26. And then we've got another dozen projects in behind that are the pre-feasibility stage. And the scale of what we can do is truly, astonishing. In total, we have over about 45 opportunities in our project funnel, about 30 million tons of potential biogenic CO2 to be captured. So we're really building the largest carbon removal network in the world. So that's what I'm excited about.
And Julie, these guys are rock stars when it comes to the CDR world. Let's be open about that. These and when John says pioneering, it sounds like a very modest, but this is really, they are opening the market for this, because CDR sales and being able to secure revenues for these type of projects, it is not an easy task, and it requires not just that you can capture the CO2, but you can do it in a sustainable way. All of these things are now in the voluntary market. So the companies that are out there buying these credits, they need to know that it's high quality from every angle. And we've certainly seen how much scrutiny all of our projects, all of our products have to go through in order to be able to be delivering into these projects. But of course, this has been really important for our company as well, because we continue to set high standards to all the things that we deliver. And this and of course, if you ought to deliver such a product like a CDR, you should be certainly very, very clear that this is not just good for the wallet of the developers, but more for the environment. And this is what we're seeing, of course, as well. Julie, a lot of fun questions in the chat. I can see there are people saying hello from Kalundborg in Denmark, which is, of course, we're delivering plants at the moment. So it's fun to see that the excitement down there. Yeah, John.
Very good. That's very good. So just continuing on the CDR, John, and I do have a question for you there. And if there is a buyer who want to know more about you guys and get involved, how do they just call you?
Yeah, look. Just to answer the question, but also pick up a couple things that JC said. We as a project developer, we're developing these projects, but we've taken I'll call it a customer obsession approach to what we do. Everything we do really starts with how do we deliver and provide confidence and reliability and low risk execution for our CDR buyers. So these are some of the largest companies in the world. They've got very deliberative and aggressive goals to get to net zero. And so understanding their requirements is something we really focus on. We're really proud of. We have I mentioned Natalie Katikian, my co-founder, and she runs all of our commercial team. This is a team I think that is I think they're the best in the world, but I'm biased. They get up every single morning and they work with buyers at all stages in their net zero journey. And it's not easy to buy CDR. There's lots of choices. There's lots of due diligence. There's lots of convincing of within their organizations about what the value proposition is to buy CDR. And our team works hand in hand with our project team, our engineering team, our project finance team to create the right solution for those buyers. And so by all means, reach out to us. Reach out to us through our website is probably the easiest way. And I would say, we'll do our best to convince you that our CDR is the highest quality. It's met the highest standards of the world's leading buyers. We've learned a lot. We're continuing to learn a lot. And I think one of the things that sets us apart is that we're extremely transparent as a company. We're very collaborative and partnership oriented. And you really have to be to be successful in this business.
Okay.
Good. No, I can certainly attest that, and you know, it's a lot. Not that, you know, it sounds like these type of developments are very easy, but it's very difficult. And you know, we need a separate session to talk about the full value chain, John, because, you know, just the
100%.
magnitude of the complexity, not only for the technology that we're talking about today, but also the transport and storage piece of this is quite amazing. And it needs a lot of stamina. You know, not all projects make it through. You know, we've seen now over the last couple of months how difficult it is in some of the countries in Europe that are running large-scale subsidy campaigns, and where more and more people are trying their best to get into this. But it's still very much, you know, driven by the fact that you can piece all of the puzzles together, and it should not be underestimated.
Yeah, it's a really good point, JC. That and just to put that in context, I think we first met in Oslo in 2023, and we started working on the first project in early 24. And put the whole pilot together. It arrived on site in August of 2024, and then it ran for about a year until May of this year. But that first project has taken about 2.5 years from concept now to until FID next year, and then it'll take 2.5 years to build and to get to COD. So this requires a lot of stamina, requires a lot of capital, requires a lot of relentlessness. We should definitely talk more about the value chain at some point, JC. They're complicated. Our first project is completely sold out, so don't wait if you're a CDR buyer. Come and talk to us. Our second project is in final, due diligence with some of the largest buyers in the world, and that project will shortly be sold out. And now we're developing, the next couple projects we're now bringing into the market as well. We'd be happy to take people to pulp mills. I was just with about most of our team. We were down at a pulp mill in the Gulf Coast with a group of buyers for 2 days, and it was a fantastic event because they learned all about how the whole pulp and paper value chain works, where the CDR is generated. How do we implement a project? How does the community react? What's the impact of these projects on the local community, on the pulp and paper industry? So it's a fantastic event. So those are the kinds of things we do with buyers. So we'd love to hear from people.
Very good. I've made a note that we will repeat this on the value chain early next year. So don't you worry, you'll get an invite for that. I see we're kind of nearing the end. So I have one last question here, and JC, maybe you can take a stab at this. For the mills that's out there, why should they work with you guys in CO280 and in SLB Capturi?
I think one of the, and I think you touched upon it, John. In order to pull these type of projects together, you need a different mindset, and actually thinking of everything like a partnership. This is really important because there's going to be so many difficulties along the way, and if you're not really tied into the project, if you're only getting a check in the mail after the project has been finished, you're probably not going to get there. So being able to work in a different way, working, very collaborative, working together in order to challenge some of the things that come up during the way, and find I would say, an ecosystem even that works. That is what we've seen with our collaboration with CO280. That is why, the likes of Microsoft and others have put their trust in these projects because they see that the completeness of the project, that we're able to pull it off and deliver on our promises. And it's not easy. Not all projects will make it to the finish line. It's a lot of things that needs to fall in place. But I think our ambition is not to do it once and never do it again. Our ambition is to create a playbook to repeat and get better and better and better. And that's been from the early days in Aker to all the way up to where we are with SLB Capturi and with our collaboration with CO2. That's what it's all about.
Yeah, I think Julie, just to underscore a couple of things JC said, we have a very firm concept of how we work and collaborate with all the partners in the value chain, and beginning with the pulp and paper company. I mean, these projects, we've designed a business model that effectively, creates a joint venture partnership with our pulp and paper partners that returns the most significant impact that a pulp and paper company can have is by putting one of these projects at their site. These projects will double or triple the EBITDA of these mills at a time when the industry is facing some pretty significant headwinds from offshore competition, and that stability of revenue that we're basically monetizing a byproduct that's going up stack today, and doing it in a business model structure that's more akin to the oil and gas industry. So we're bringing kind of an oil and gas type of business model to make sure that there's a sharing of risks and benefits across that value chain. And then it's really important for us as the project developer to understand, what are our technology companies partners' goals? What's SLB Capturi need to achieve? How are they thinking about scaling up? What do our transport and storage partners need? What do our project investors need? So we have this philosophy of transparency and collaboration across the value chain of partners. Everybody's got to win, and in particular, our CDR buyers have to be, at the end of the day, they have to be confident that we're delivering what they need at scale.
Very good. That's all we have time for today. So I want to thank Jonathan Rohn and Jon Kristoffer Knutsen, and to everyone that joined us from all across the world, all the corners of the world. If you guys want to follow the progress of upcoming pulp and paper carbon capture projects, make sure you follow both CO280 and SLB Capturi on LinkedIn. You can also learn more by visiting co280.com and capturi.slb.com. And with that, I wish you all a great rest of your day.
Thank you, Julie. Thanks, JC.